Yeah, good evening. This is Sharif. First of all, thank you for giving this opportunity, Data Minds Training Institute. So, in this demo session, I'm going to cover you the core concept of a data science. At the end, I'm going to represent the project that I have already done. So, let us discuss the core thing. What is data science? So, this is the notes that I have made basis on my analysis. So let us come to the core concept. So what is a data science? So here we have a concept of artificial intelligence, machine learning, deep learning. Lot of people are basically confused like what is artificial intelligence, what is machine learning, deep learning, and how NLP and Gen AI is related to it. So here I have given a good definition, simple definition to remember what is artificial intelligence. So I will give my own way of example. Like basically, a human brain consists of a combination of neurons which are interconnected. What we call when you have a neurons inside a brain, biological neural network. Like that, if you take this combination of a neuron which are interconnected to each other and you fit inside a computer system, what we call is artificial neural network. So using artificial neural network, you are getting artificial intelligence, which is a field of a computer science. Basically it aims to create the machines or systems like they can think, reason, and make decisions like humans. So here the main agenda is to recognize patterns, solve patterns, and perform tasks intelligently like a human. So here we have machine learning. So here you can see this inside an artificial intelligence. Artificial intelligence is like a big ocean. So what is machine learning? Machine learning is basically a subset inside this artificial intelligence. So machine learning is basically a subset of a artificial intelligence in which computer they learn patterns using a statistical techniques, or we can call it as tools. The main first thing the machine learning algorithms will do is to learn and identify the relationship between the data and also detect the patterns and apply statistical tools to analyze the data. So this is the thing which is done by the machine learning. So now coming to a deep learning, how it is integrated with the machine learning. So here you can see machine learning is basically a subset of deep learning is basically a subset of machine learning. Machine learning, inside machine learning, so I'm going to give you a good example how machine learning and differentiate between the machine learning and the deep learning. Out of the 100% of data that we are operating, 90 and more than 90% of the data is the raw data, and the very less data, less than 10% of the data that we are dealing is the structured data. So structured data is very less and raw data is basically more than 90%. So we used to have a structural data which is less than 10%. So in order to deal with this data, which is represented in the form of a numerical structure, scientists and the researchers, they found the machine learning algorithms, and the algorithms were designed in that way to deal with the numerical data. Coming to the unstructured data, what is unstructured data? Unstructured data is the raw fact and figures like images, audios, videos. In order to deal with this data, deep learning models were developed and emerged and get over time they became popular after 2012. Okay, so now you can see here this artificial intelligence is a complete ocean. You will have a subset again inside it like a machine learning, and inside machine learning you have a subset again that is deep learning. Now what is generative AI? Okay, so here you can see a complete picture. You have one more thing called NLP. So what is NLP? So NLP is basically as researchers and the scientists who are successful for finding a good models for structural data, that is machine learning. Unstructured data, images, audios, videos, deep learning. So what is the need of NLP? NLP stands for Natural Language Processing, is a field of artificial intelligence that helps the computers to understand, intercept, and respond to a human language in a way that is meaningful and useful. So we can perform the tasks like sentiment analysis, text classification, language, text to speech, speech to text. So NLP is especially introduced in order to deal with the human language, that is a sentence. So where NLP fits, a lot of people are confused with this kind of flow. So what is machine learning, deep learning, NLP, how are they are related to each other? The answer is they are not completely related to each other. They can be recognized as a subset internally. So here where NLP fits. So NLP is not strictly a subset of a deep learning, but they are closely interconnected. So here we can use ML or deep learning techniques to process and understand text. So early NLP is basically used the statistical approach or rule based, and later bag of words, which was introduced in their 1960s, and also TF-IDF, which is introduced in 1972, O2 Vector 2013, 2014 Globe. These kinds of models has changed the today's world. So here modern NLP heavily relies on deep learning models. So the operations performed inside the NLP are pre-processing, which is nothing but tokenization, stop words, removal, lemmatization, and bag of words. I'm giving you just a blueprint. I can tell this concept in depth, but as this is a demo video, I'm giving you a simple description regarding this. So representation here you can see bag of words, which came around 1960, 1972 at TF-IDF, O2VEC 2013, 2014, and BERT is 2018 model. And here you have a LSTM model, which is an algorithm especially known for the sequential. This is the first algorithm which was experimented on a sequential data. And both 2018 GPT models released like 2018, 19, 20, as we're experiencing today as a chatbot, and decoding grammar post-processing process. So here you can see a frame where machine learning has a traditional machine learning methods like this deep learning, and NLP focus of the field of AI focus on human language. So now I'm gonna show you how the machine learning models are represented through the years. So linear regression 1805 came in 1957, logistic regression 1958. So this is the deep deep learning model SLP, single layer perception, or we called it as perceptron, which was introduced in 1958 by Frank Rosenfeld. So what is the specialty of the algorithm? This algorithm has told a human like it can correct the mistakes by itself during a backward propagation. So before these algorithms, the scientists and the researchers, they were successful in learning the patterns between the data and establishing the relationship. But this algorithm has proved that the algorithms can correct its own mistakes made by them, so which has exhibit like the behavior of a human almost. And here after that, these are the machine learning. This particular algorithms were designed for a numerical data, especially in order to handle the numerical data, KNN, namespace, support vector machine, random forest, and boosting algorithms came then. These are the strong model. The boosting algorithms is a combination of weak learners, like hundreds of weak learners. We can call it as hundreds of decision trees which are stacked together to form a boosting models like gradient boost, XGBoost, ADA boost. These are the light GBM and the cat boost. So now coming to this, so I think now you got a clarity. What is AI is a complete version. I will go with this image. AI is a complete image. Machine learning is a subset which is usually designed from this evolution has started from 1806, and we have experienced so many algorithms, and then deep learning came after 1950s. So first algorithm was SLP, later various kinds of algorithm came, then NLP, Gen AI. What is Gen AI? Generative AI. is basically is used to create a new data which has never existed before from the existed data. So we use the LangChain framework in order to create that. So here we have a AI tools like self-driving car and an app and machine learning. And here in this machine learning kind of algorithms, we have two types like supervised machine learning, unsupervised machine learning. In supervised machine learning, you have a data with both inputs and outputs are labeled together. And unsupervised machine learning, you don't have data labeled together. You only have inputs. And reinforcement learning, some part is labeled and some part is unlabeled. So like this, we have different types of you know data arranged. And so now we will conclude what is data science. Now we know what is artificial intelligence, machine learning, deep learning. So when you combine this all together along with what statistics, probability, linear algebra to form a data science. So here you have a concept called TensorFlow. In this, PyTorch is there, TensorFlow is there, PyTorch from Facebook, and TensorFlow from the Google. So here, this framework, what is the framework? Framework is basically, it facilitates the algorithm training step by step. So I'm gonna give you a simple example. When the student is giving his exam, you will have a room to attend and write the exam. So the bench is facilitating the students exam, and the window which is meant for ventilation is also facilitating the students exam. This can the anything which facilitates the model training can be called as a TensorFlow framework and a PyTorch framework. So now coming to get back to the things. So give me a minute. So now coming to, I think I've covered the basic things. So these are the deep learning models which are like introduced. Here we have AlexNet 2012, ZFNet 2013, BGG16, and GoogleNet, RESTNet, MobileNet. All of these algorithms are introduced. So here I will give you a good story about AlexNet, who is Geoffrey Hilton, who is the godfather of AI, has invented this AlexNet. This was the first algorithm which has performed with this much of error rate, that is 16.4. Has given a very good performance for the first time for the colored images. So the algorithms before this, like 1998, Linet 5 and CNN models were successful for the grayscale images, but this algorithm is something different and which has recognized all over the world. Now coming to, this is the thing, coming to the project that I have did, I will show you that. So this is the project. So give me like 1 minute, it will take some time to load. I have deployed this project using a render. Okay, it will load anyway. So this is the complete blueprint I have given you in a simple short manner. So how the things are arranged and what is data science and how AI, ML, DL are integrated with it. So let us will show how the project is made with the machine learning, and also have implemented a chatbot using LM. So this is the project. Detect threats with precision. So cyberquad is basically combines the state-of-the-art machine learning models to identify phishing URLs. So here I will give this explanation in a simple way. So what I have done is I have using the machine learning models, random forest, like GBM, XGBoost, KNN, decision tree, logistic regression in the back-end training, and basis on this training result, that is accuracy, the algorithms that I got highest accuracy I have implemented in the front end. and I used one LLM model, and this LLM model is trained with the lang chain framework, and the algorithm name is this EMA 3.370 billion. So here you can see predictions. You have three types of predictions. So this is the models page. So you can see we got 99.977 accuracy for the algorithm. Coming to the first kind of prediction, that is URL prediction. So when you insert a URL, so when you analyze this here, you can see this legitimate. So this is the safe, and I'm giving another URL. This particular data is the works for the real time. So here it is just detecting the phishing. So okay, here the thing is, here you have a HTTPS. As you know, S means secured, but still it is showing a phishing, because actually this particular URL belongs to the phishing kind of pattern. So this is what, like HTTPS, sometimes it can be a phishing. So that is what this algorithm is showing differently in this kind of project. So here we are doing another kind of URL, so phishing. So next, cyber attack. This prediction is made based on the futures. So here we are giving some different values, 15, tap 67. Here we are giving some random values in order to predict the output, and 6. So these are the network flow futures. The duration is all. So by use for this network flow futures, I am detecting the attack. So we got 1. So we have this type of attacks: total, backdoor, DOS, generate, prop, worm. So we got this like this. For different kind of inputs, you will get a different kind of output. And you have a AI system. This part is interesting. Here we implemented the RAG implementation for the LLM, retrieval augmented generation. Here suppose I give a simple hi to this model. So it is giving hello, I am cyberbot AI system. Oh good, so cool. And I am giving this message to, so I have mentioned what features are we extracting from URLs in this project. It is mentioning this kind of, I am using this kind of features, length of URL, domain length, and I am doing one more question: what algorithms or what models did you? So yeah, it has given like URL phishing detection. I'm using a random forest model which has given this much of accuracy. For cyber attack detection, I'm using a light GBM. This is 2016 model, especially known for categorical split, and 99.16 given. And here you are using this particular LLM model, which is a well-known model which has trained, you can see here, 70 billion parameters LLM for a chartboard, like what is we are implementing in this project. So yeah, this is about the meet. Once again, thank you for giving this opportunity. So I would like to have further rounds after this. I hope this will grab the good attention from you. Yeah, thank you.